The transition to electric vehicles is gaining momentum. This shift is driven by the urgent need to combat climate change and reduce our reliance on fossil fuels. Electric vehicles offer a promising solution. However, there's a hidden challenge in this revolution. Rare earth materials. These elements, like neodymium and dysprosium, are essential components of EV motors. They provide the strong magnetic fields necessary for these vehicles to operate efficiently. While EVs themselves are designed to be eco-friendly, the mining and processing of rare earths can have significant environmental and social consequences. This reality presents a critical challenge to the sustainability of the EV industry. To ensure a genuinely green future for transportation, we must find ways to lessen our reliance on these materials. This means exploring alternative materials and innovative technologies. The good news is that researchers, engineers, and automotive companies are actively seeking solutions to reduce or eliminate the use of rare earths in EVs. This global effort involves exploring a range of promising avenues. One approach is to develop new types of electric motors that rely on different magnetic materials or motor designs that minimize or eliminate the need for rare earths altogether. The environmental impact of rare earth mining is a pressing concern. The extraction process often involves open-pit mining, which can lead to deforestation, habitat destruction, and soil erosion. Furthermore, the chemicals used in the extraction and processing of rare earths can leach into water sources, contaminating rivers and groundwater. This pollution poses serious risks to both human health and ecosystems. Beyond environmental concerns, the reliance on rare earths raises geopolitical issues. The global supply chain for these materials is currently dominated by a single country, China. This concentration of production creates vulnerabilities and potential disruptions to the supply of these critical elements. The reliance on a single source for a resource as vital as rare earths makes the EV industry susceptible to price fluctuations, supply chain bottlenecks, and even political tensions. Despite the challenges, there is hope for a future where EVs are not only emission-free, but also produced with a significantly reduced reliance on rare earths. Several innovative companies and research institutions are leading the charge in developing sustainable solutions. One promising avenue is the development of rare earth-free motors. Companies like Tesla, BMW, and Renault are exploring alternatives such as ferrite magnets, which are made from more abundant and less environmentally damaging materials. Another approach is to improve the recycling and recovery of rare earths from end-of-life products, including EVs. By implementing efficient recycling programs, we can create a more circular economy for these materials, reducing the need for new mining operations. Companies like American Manganese Inc. and Redwood Materials are pioneering new technologies to recover lithium, cobalt, nickel, and other critical minerals from used batteries. The journey towards a truly sustainable EV industry requires a collective effort from governments, manufacturers, researchers, and consumers alike. Governments play a crucial role in incentivizing the development and adoption of sustainable technologies through policies that support research and innovation in rare earth-free alternatives, as well as regulations that promote responsible sourcing and recycling practices. Consumers also have a role to play by demanding transparency in supply chains and supporting companies that prioritize sustainability. The future of mobility is electric, but it must also be sustainable. By embracing innovation, adopting responsible practices, and working together, we can create an EV industry that is both environmentally sound and ethically sourced. The transition to a greener future for transportation depends on our collective commitment to finding solutions that benefit both the planet and future generations.